Okay, so let's start with our second example. Let's first find the parent chain. Let's look for the longest chain in this molecule. If we start with this carbon or this carbon or this carbon, it wouldn't matter because the location of your ethyl groups is going to be the same. So let's try to see what I mean. So let's start with counting from this side. 1, 2, 3, 4, 5. You're counting your carbons, right? So the methyls group will be on carbon 2, two methyl groups. Let's start from this side. 1, 2, 3, 4, 5. Same, carbons will be on carbon 2. What if we'll start from this side? 1, 2, 3, 4, 5. Again, this carbon and this carbon will be still attached to carbon 2. What if we'll count from this side? Let's start from right to left. 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. Or this way, 5. As you can see, we prefer the smallest number for any attached groups. And this from left to right is going to be more desirable because your methyl groups will be on carbon 2 instead of carbon 5, right? So we have two methyl groups and the parent name for this molecule is going to have 5 carbons. Therefore, and all of the bonds over here are single, as you can see. If there is no bond, like in this molecule, the bond is not shown or shown like this, it means that all of the bonds are single. So it's alkane, and the suffix is going to be ane. 5 is pent, so we can write the parent name. It's the pentane, and then we have two methyl groups, and then we have to specify at what carbon they are. So both of those methyl groups are at carbon 2, right? 1, 2, 3, 4, 5. So, and there are two. We have to make sure that we specify each one of them where they are. What if there would be two methyl groups but they were at carbon 2 and 3, or 2 and 4, or at 1 and 3? Something like this. You would have to write different numbers, but since they're both attached to carbon number 2, you write carbon 2, and the second is at 2 as well. Then we have 2. 2 is going to be di, and your ethyl group, which consists of one carbon is methyl pentane. So the full name of this molecule is 2,2 dimethylpentane. Let's move on to the next one. So this molecule over here has a double bond and couple of methyl groups that are attached to carbons. So when you name anything that has a double or triple bond, they will always have the priority regarding where it's located. You will always start from that end. The double bond that is closer to one end, that's where you start your counting. It doesn't matter where the attached groups are, right? The alkyl groups, because double bond has the priority. So we know that we'll start at this carbon. Let's find the longest chain. So 1, 2, 3. We can go this way. Or 1, 2, 3, 4. We can go this way. Or 1, 2, 3, 4. So we now see that the longest chain has 4 carbons and there's a double bond over here. So this is alkene. So we can write 4 is bute, and then double bond from alkene has a suffix ene. So we know this is our butene. Then we have to specify at what carbon is the double bond. So it starts at first carbon, right? It is attached to your first carbon. So you specified that it's at first carbon. And then don't forget about our methyl groups. Here's one carbon and here's one carbon, right? That do not belong into our parent chain. They just attached to different carbons. We have to make sure we include them as well. So we started from here. 1, 2, there's one at carbon number 2, and 3, there's one at carbon number 3. So we include them as well. 3, we have 2 identical ones, right? Both of them are methyls. So we write di and then we include methyl. And there you go. This is the name of your next molecule. 2, 3 dimethyl 1-butene. There's also a possible way of writing this writing the name for this molecule is this way. So you're just specifying that the double bond as at first carbon this way. Either way is correct. So you pick whichever is easier for you. Okay, let's look at this skeletal structure. So we can see that there's a double bond in the middle, right? But let's find the longest chain. So if there's a double bond, we can write right away that there is "-ene", the suffix "-ene". What is the longest chain? 1, 2, 3, 4. So we will have a double bond at 2, and we will have a methyl group at 2 as well on the second carbon. Let's start with this one. 1, 2, 3, 4. The double bond is going to be at second carbon, but the methyl group is going to be on your third carbon, which is not really desirable because you want to have the smallest numbers as possible. If we'll count from this side? 1, 2, 3, 4. The same way if you would be counting on this carbon. So it doesn't matter. Each way you want to go, it's still going to have the same name. So 4 carbons in your longest chain. So you write butene, right? And then you specified that your double bond is at second carbon. 2, because 1, 2, or 1, 2. And you also make sure that you include that alkyl group that is attached to the second carbon as well. Here it is. Or if you started counting from this side, this way, you can include this one. It doesn't matter, it's going to be the same name. So 2-methyl 2-butene. Since there was only one methyl, we do not include anything. Okay, let's move on to the next one. So this is a little bit easier because you can see right away where we will start from. So double bond is located much closer to this end than to this end. And as we remember that double bond or triple bond always have the priority. So we'll start from this side. And as you can see, this is our long chain. You can see it right away, right? So here's our parent chain. And this is going to be our alkyl group. So 1, 2, 3, 4, 5, 6, 7. 7 carbons. 7 carbons is "-hapt", and then double bond is "-ene". We have to specify where is the double bond. It's at second carbon, right? It is located between second and third carbon, but we mentioned that it's a second carbon. If we would start from this side, let's see what would be the second carbon at. 1, 2, 3, 4, 5. So it would be much larger number, right? We don't want a larger number. We want a smaller number. So we don't want to forget about this methyl group, right? And it's located at 1, 2, 3, third carbon. So you include 3 methyl, 2 heptene. Okay. Let's move on to the next one. So this one is easy because it's alkane, only single bonds everywhere. You just need to find the longest chain, parent chain, and then see if there are any alkyl groups attached to your parent chain. So let's start from this end. 1, 2, 3, 4, 5, 6. 6 if you start from this end. And then let's see where is our alkyl group. So this would be our methyl group that is attached to 1, 2, 3, to your third carbon, right? So let's write it just like a possibility. 3 methyl, and 6 is hexane. The ending is ane because it's alkane, right? Let's have another possibility and then we'll pick from all our possibilities what are the best ones. So let's start to count from this end. 1, 2, 3, 4, 5, 6. Still 6. 1, 2, 3, 4. But now methyl group is on the fourth carbon. So this would be the other name. Let's start from this carbon and see how it's gonna go. 1, 2, 3, 4, 5. 5 carbons, so it's not long enough, and then you'll have ethyl group at your second carbon. So you would have 2 ethyl pentane. Or we can start from this side. 1, 2, 3, 4, 5. Again, pentane, right? And then you would have your ethyl group, right? Because there are 2 carbons over here at 1, 2, 3, 4. So 4 on the fourth carbon, right? Ethyl pentane. You can write all possible names and then pick the correct one. And as you can see, the last 2 are incorrect because your chain is not long enough as hexane. So we can delete these 2. These are definitely incorrect. If you can compare 3 and 4, you know that 3 is much smaller, is 1 digit smaller than 4. So 3-methylhexane will be the more desirable name. So this is the correct name, 3-methylhexane. 2 more. Let's look at this. This is an easier one as well. This is just a long chain with no alkyl groups attached to it. So you just need to specify where is your second double bond. Is it at second carbon or is it at 1, 2, 3? Is it at third? So 2 is smaller number comparing to 3. So we'll start at 2. We'll start counting from right side. So 1, 2, 3, 4, 5. Double bond means it's pentene, and then you specify where is your double bond and what carbon it is located. 1, 2. It is located between 2 and 3, but you write the smaller number, 2. If it would be writing from this side, it would be between 3 and 4, right? And then you would be writing 3, but if you would have more carbons. And the last one is easy as well, but over here we have a triple bond. What is the triple bond? It has the suffix "-ine" because it's part of alkyne. Let's count how many carbons do we have. 1, 2, 3, 4. And as you can see, no matter which way you'll go, it will be the same. If you go from this side, 1, 2, 3, 4, still will be 4. So we can write butane. So where is our triple bond located? It is located between 1, 2, 3, 4 or 1, 2, 3, 4. Either way you go, it's still located between second and third carbon. So we can write 2-butene, or you can write butane. I'm sorry, butane, not butene. I made a mistake the first time. So this is how you go. So your book has more examples, but it's not on naming, it's actually identifying the type of hydrocarbon. And we'll concentrate on identifying the hydrocarbons. Here's a small table for you that I created next time. So when you will be more comfortable with the rest of the problems.